Um, Let me kind of clip this guy. So here you have, these are called parametric equations. Okay, with theta is the parameter. Okay, it's the parameter. So since you guys know your friends so well, fill this table in. If you have issues filling it in with your friend's table, get a calculator out. You're going to need a calculator anyway, because you know that pi over 4, cosine pi over 4 is going to be root 2 over 2. Well, how are you going to put root 2 over 2 on a graph paper? Right? What's root 2 over 2? 0.707. Okay? So, you're going to graph this at the end, right? So, how else are you going to graph this, right? Right? Does that make sense? Okay. So, can you guys fill this table and then graph that? All right. Let's take a look at doing this on the graphing calculator. So, you need to get your graphing calculator out. Mine's right here. Yeah, it'll be all done by the time you come back. Yeah, just watch and then you can come back and do it. Okay, people, listen up. Myra, listen up. Zach, Ian, what?
I was just
Oh, my bad. Myra, you want to erase the board there? Thank you. Okay, first thing, Leah, graphing calculator. Okay, mode. Do you see func, PAR, POL, SEQ? We've been in func mode forever and ever and ever. Today we go to PAR, parametric. Okay? Hit enter. And then if you go into y equals, note how it changes. Mode, parametric, PAR. And then if you go y equals, see how it changes? You got x1t, x2t. Okay, t is the parameter now. Okay, so instead of theta, they're using t. They're going to use theta later on for another type of graphing that we're going to do tomorrow called polar. Okay, so here we're going to put our equations. Make sure your calculator is in radian mode. Okay, and we're going to go cosine. And where you put in t's, see where you see x, t, theta, and n? See this thing? Do you see my cursor moving around there? Can you see that? Okay. On that key, you've got x, which is function, t for parametric, theta for polar, and n for SEQ. Okay, we're going to do all these modes, okay? Not today, but over time. So if I hit t, that's what I get. And y was equal to 3 sine t, 3 sine theta. Is everybody okay on that? So you're going to go 3 sine, and you're going to graph that. Well, I need to change my scale, so just do zoom standard. And right there is the kind of graph that Myra drew. What shape is this? Sorry? It's an ellipse. It's an ellipse. It's an ellipse. Everybody there? Everybody caught up on the 84? What's up? All right, everybody get that? All right, is everybody there on the 84? Okay. All right, let's go on. How to change the parametric curves to what I call rectangular or Cartesian. In other words, you want to get rid of the parameter. So in here, the parameter is what? What's the parameter in these equations here? Sorry? Theta? I want to get rid of that and just have an equation in x and y. Okay? Josh, being the pickup artist that you are, what's the pickup identity? What's the pickup identity? What? Oh my God! Did you get a date for prom yet? How did you pick her up then? Beta, you want to bail him out?
Wait, I don't know.
Pick up identity. You should know this one.
Sine plus cosine equals 1.
Not sine, but
Square.
sine squared. If you are sine squared theta and I'm cosine squared theta, together we are 1. Can't forget that. I can't forget that. So can you use this identity and do stuff to this to get rid of theta? Well, do it then. Square it. Right? Square it. Except before you square sine, what you're going to do? Divide by 3. Okay? And what do you get? What?
What are we doing? How are we supposed to?
Okay. All right. Let me help you out here. What's sine theta equal to in here? From that second equation. Y over 3. So why are we? Why are we doing this?
Yeah, like why? Yeah.
Oh, you'll see in a minute why. Yeah, you'll see in a minute why. Everybody gets sine theta equals y over 3. If you square this guy, you get y squared over 9. Yes? If you squared cosine squared, what do you get? What do you get? X squared. And then if you add the 2, what do you get? 1 equals x squared plus y squared over 9. Is everybody with me on that? Yeah? Yes? Surabhi, yes? Okay. Well, you recognize what this is. Sorry? It's an ellipse. Isn't that what we graphed? Okay. So here's the reason why we are doing this, because it's quite possible you'll get a familiar figure that you know. Okay. Whereas if you are to look at it in this form, it might not be obvious. Okay. Whereas in rectangular form, you know, you've seen these before. All right. Is everybody okay on that? You guys, so what we just did is we went from parametric, okay, to what I call rectangular or Cartesian. Okay, same thing. Okay, so we did this conversion here like that. You guys with me?